Hello, we will talk about the high level or big picture signaling in terms of the data rate in a SerDes architecture. But we never talk about the high level design considerations in terms of the clock rate in a SerDes architecture. Therefore, people may think that we should generate or recover the data at the TX and RX respectively through the clock rate same as the data rate, which is called full rate clock SerDes. For example, we apply the 10 GHz clock frequency to generate the 10 gigabit per second TX data sent to the RX, and the RX CDR recover the 10 GHz clock frequency to recover the 10 gigabit per second RX data into the paired data and clock. Is that necessary? In other words, can we do the half-rate clocking SerDes? If yes, why do we want to do that? Since this talk is a high-level discussion, let's skip how to do the half-rate clocking SerDes at each block level in detail. Bear with me in a few talks or videos, and I will show you how to implement those half-rate clocking topology on each block level of the SerDes. Then you will have a better understanding why those half-rate blocks help make the whole half-rate SerDes better than the full-rate SerDes. Guess what would be the first advantage of the half-rate SerDes you can think of? Bingo! Power. To design a low jitter TXPL, the higher frequency will require more current to reduce the thermal noise than the lower frequency, especially for the most noise contributor VCO, which is the most power hungry. Similarly, the RX CDR's high frequency jitter must be as low as possible to improve the RX equivalent I width, since the CDR's low pass tracking behavior cannot track its intrinsic high frequency jitter, which would require burning more power to reduce it. Instead, reducing the clock frequency would save power to keep the same required high frequency jitter requirements. Furthermore, we only show a single lane SerDes, and you may have 4 lane or even 8 lanes SerDes. Then the clock distribution between those 8 lanes will become a very power hungry. To save power at the most advanced process node, we may prefer CMOS clock distribution instead of the traditional CMOS clock buffer. Then the CVF curve may show you a half-rate clock frequency may result in only half current or power in your clock distribution, no matter at the TX clocking or even the RX clocking if needed. What's more, think about the current or switching activity for 5 seconds. Yes, reliability. Think about the difference between the 10 gigabit per second PRBS data and 10 GHz clocking signal. Correct. The 10 GHz clocking has the most switching activity compared to the 10 gigabit per second PRBS data, which may have a static 1 over 0 for a while. Therefore, the clocking path clock may suffer from aging more than other data path blocks. To extend the clocking block's lifetime, the CVF current of the half-rate clocking is almost half, and its self-heating issue is much less than full-rate clock. In addition, the electromigration EM requirement at the half rate is less than the full rate. The metal routing would help reduce the parasitic loss and make the transition time between 1 and 0 much faster and lead to a more reliable in HCI hard carrier injection for the devices in the cloud path. What are the advantages of the half rate? Think about the signal integrity in rise and fall time for 5 seconds. Great. Avoid the path swallow issue at any node of the cloud path. Assuming the same buffer fan out along with the same loading in the clock routing according to the CVF power budget should provide the clock signals rise and fall time. Then simply double the clock period or half rate clock. You should see the clock signal has a more robust signal integrity in a square wave, which has a much less chance having path swallow in the clocking over PVT, device Monte Carlo, routing parasitic variability, extra dummy field, or even foundry model or fabrication errors. We can achieve the clocking robustness not only in your careful design in the full design cycle, but also in the first step clock architecture decision. In addition to the clock path itself, what's the extra benefit from the data being sampled by the half rate clock instead of the full rate clock? Think about the rising edge sample for 5 seconds. Bingo! If we use the clock's rising edge to sample the data, then the sampler would have twice the time to sample the next data after sampling the present data. Correct? Similarly, if we use the clock's falling edge to reset the sampler's hysteresis, then the sampler would have twice the time to reset the previous state. Therefore, the samplers used either in the CDR or DFE may have more time or operate at a higher data rate if the half rate clocking is used as the sampling rate. In other words, the input sensitivity of the CDR, DFE, or the whole RX can be improved by the half rate clocking topology. Okay, in addition to those PPA improvements, what's a simple porting use case you would transfer to a half rate? Think about the upgrade image for 5 seconds. Correct. You would like to upgrade your 10 gigabit per second in a full rate SerDes to another 20 gigabit per second in the same process node, but your design resource cannot meet the schedule. As a project manager, what can you do? Of course, you can keep your existing 10 GHz clocking without redesigning the clock path for the new 20 gigabit per second SerDes in this half rate clocking. Then you only need to redesign or retune the data path block, and hopefully that will save you extra effort into designing the clock box at 20 GHz. Here are the summarized images of why we prefer half rate clocking SerDes. Long story short, the half rate clocking helps improve the PPA of the SerDes in a low power, high reliability, and low area. Therefore, for any power constrained device like mobile phone, tablet, or any IoT device like smartwatch may not accept a full rate SerDes. In addition, for a very high density system or server, the power thermal runaway or reliability is a big concern, which can be mitigated by the hybrid clocking SerDes. For high signal integrity requirement like memory interface, automotive, industrial usage, etc., the robustness of the clock is the highest priority, and half-rate SerDes is a better choice. Going down to the sensitivity, the half-rate sampling may provide a better timing for CDR or DFE in the RX. Of course, if you like to make sure your design is compatible with the legacy SerDes or the upgraded one, the half-rate is a good option to help you keep all the benefits without spending time to redesign a higher clock rate in the schedule and design risk. Thanks for watching. Before you go, if you are benefiting from those circuit images, I would love to hear your feedback and please share your comments down below. Lastly, please share the video link with the people who may be benefiting from it.